Hello and welcome. This is Sunil, your instructor for this course, and this section is fully going to be dedicated to MongoDB sharding. So we will start from understanding what is sharding, why it is needed, and how the sharding is achieved in MongoDB, what are the components of MongoDB sharding, what is a sharded clusters, and we will also touch what are the strategies that we use for MongoDB sharding. So this section is totally and fully dedicated to the MongoDB sharding, which is the long pending topic to be covered in this particular course. So from today I'm going to add lectures for sharding in this section, and also I will be parallelly adding to the lectures in the replication section as well. So stay in touch and keep watching the course, and if you have any question, do ask in the question answer area inside the course. And this section we will cover all the theory part, concept for sharding, and then we will go inside the practical sessions where we will configure the MongoDB sharding. And parallelly I will also be adding the hands-on for the replication section as well. So this month is going to be all about replication and sharding in this course. So let's get started and see you inside the next lecture. Hello and welcome back. So in this lecture we are going to learn about sharding. So MongoDB sharding is what we are going to cover in this lecture, and in this section we will cover all about sharding in MongoDB. But in this particular lecture we are going to discuss about what is sharding and why it is needed. So let me first give you definition of sharding. So as per the definition, sharding is a method for distributing data across multiple machines. So this is the definition. Sharding is a method for distributing data across multiple machines. So now you must be thinking why we should distribute data across multiple machines. So the answer why we need sharding is hidden inside this across multiple machines sentence. So why do we need MongoDB, or why do we need sharding in the first place? So let me tell you, we use sharding to support the deployment. We use sharding to support the deployment with large data sets. Okay, so it is a method for distributing data across multiple machines which support deployments with large data sets and with very high throughput. Okay, so when we are having a very large data set and very high throughput operations, then we have to go for the sharding. So let me put some more light on this. So let me tell you, suppose we have a data set. Let me scroll down. Suppose we have a very large data set. Suppose this is a large data set, and we are doing very high throughput operations for read, write, all those things, delete, all those operations are going on this data set, and we want to keep this entire data set on a single server. So what will happen when this data set will keep on increasing and it will become very large data set over days, over time? Then it will be difficult to manage this high throughput data by this single server, because this data set is increasing but this single server capacity is not increasing. So to handle all these data set with the high throughput operations, we need to increase the capacity of this single server as well, right? And this can be done by adding more RAMs, more hard disk, all those things, right? CPU capacity and all, if we add, we can increase the IO capacity and all. But this increasing the RAM and hard disk and to CPU and all, it is very costly, because the server which we were using earlier, we need to replace this with another server, another very high efficient server, which will be very costly, right? And when we remove this server, we will replace it with another server. So this server, we have to throw it out, or we have to use it in some other way, but anyway we are going to invest a lot of money and resources in deploying a new server. And this kind of thing, increasing the RAM, hard disk for a single server, even the adding the RAM also will cost you more, right? This is known as vertical scaling. So we are scaling the server vertically, right? We are increasing the capacity of the server vertically. But MongoDB, what it does, it supports the horizontal scaling. So what is this horizontal scaling? Horizontal scaling means we have this data set. Suppose currently it is being distributed over a server 1, right? And when we need more RAM, more CPU, then what we do? We will add one more server 2, and we will distribute the data set over 2 servers. So vertical scaling involves increasing the capacity of a single server, whereas the horizontal scaling involves dividing the system data set, this data set, and load over multiple servers. So now we are dividing this data set, we are distributing this data set over the one or more servers. Okay, so this is known as horizontal scaling, and this is what MongoDB supports. So now the workload of this high throughput large data set is being handled by these 2 servers. If over time we need one more capacity, we can add one more server here, server 3, and this data set will be distributed over 3. So in this way we can add more scalability to the server by adding one or more machines, and each machines will be very low configured machines, but they can handle the small data set of this large data set, right? So they are not going to handle this entire data set. If you put entire data set on a single server, it will collapse. But when we distribute this data set over 1 or 2 machines, different servers, they can handle it well. So this is what known as horizontal scaling. So horizontal scaling involves dividing the system data set and load over multiple servers, adding additional servers to increase capacity as required. While the overall speed and capacity of a single machine may not be high, so what does it mean? This server 1 capacity is not as high as required to handle all this data set, but it is quite lower, but it will work with server 2 and server 3. So all these 3 together can handle the data set pretty well. Each machine handles a subset of overall workload, potentially providing better efficiency than a single high-speed, high-capacity server. So these 3 together can perform much better than the single high-speed and high-capacity server. So this is why we go for the horizontal scaling, which is very less in cost and it is very easy to configure and deploy. And that's what horizontal scaling is all about, and MongoDB supports this horizontal scaling through the sharding. So horizontal scaling through sharding. So Sharding is somewhat horizontal scaling of the servers to handle the large dataset with high throughput operations. So we will see in the next lecture what is sharded cluster in MongoDB, and I hope you understood why we are going with the single server to multiple server horizontal scaling, because single server can be very costly to upgrade, but when we go with the multiple servers, it is easy to add one more server here, server 4, and thus it is very easy to and low cost to maintain also and add more servers over the time. So see you in the next lecture where we'll be discussing about the sharding clusters and all. Hello and welcome back. So in this lecture we are going to learn about sharded clusters, and we will also see how the sharding architecture look like in MongoDB. So we will see about sharded cluster in this lecture. Okay, so this is what we are going to see in this lecture. So let me tell you. So this sharded cluster is going to be in 2 or more lectures. So I'm not going to cover in one lecture. I'll split into 1 or more lectures so that we can understand better. So in this I will simply tell you what are the components of the sharded cluster and how it looks, and in the next lecture we will see in more detail. So sharded cluster has 3 main components. So the first component is known as shard. So shard, okay, so the first component is shard. The next component is MongoS. So MongoS you must have seen in while installing the MongoDB. In binaries, when you unzip it, you must be seeing the MongoD, Mongo, and in that you must have seen MongoS also. So it comes with the MongoDB installation, so you could have seen this, right? So MongoS, and the next is config servers. So these 3 are the main 3 component of the sharded cluster. So what is shard? Shard is actually it's a subset of the data. So we know that we are splitting the data. We are splitting the data set over multiple machines. So each shard will contain the subset of data. So it is actually a subset of data, subset of the data set, sharded data, right? Data, subset of data. Okay, and actually each shard is like a replica set. So replica set. So I will tell you in the next lecture how actually it is a replica set, but for now it is okay to know that each shard is a set of replica sets. So replica set will contain multiple hosts, like host 1, host 2, like that, right? So whatever data we are sharding, the subset of data, it will be splitted over the multiple hosts, multiple machines, and that's why it's a replica set. Okay, so each shard will contain a replica set, okay, or host of machines. So shard is actually a subset of data that we are splitting over the multiple machines. So one sharded cluster can contain multiple shards. Okay, so next thing is MongoS. So what is MongoS? MongoS actually it's a router, it's a query router for this cluster. Sorry, extremely sorry. It's a query router. It's a query router. So what happens in the sharded cluster, we will have the different shards. Suppose one shard here, one shard here, one shard here. So suppose this shard 1, shard 2, shard 3. So we'll see in detail in the next lecture, but here just to understand. So what I said in this SARD is actually a replica set. Okay, and this is also one replica set, and this is also one replica set containing different documents and all, and if on the different host. So now suppose we have a app server here, application running here, and I want to access this data or SARDs. I cannot directly access these. To access this, what I need to go through the MongoS. So MongoS will be here in between the app server and the SARDs, and whatever I want to query, whatever I want to know, I have to go through the MongoS, and MongoS will be fetching the data and giving it back to the app server. So all the query and all, it should be routed through the MongoS in app cluster. So this is one important thing to know. Okay, so this is what the MongoS, it's a interface between the client application, this app server client application, and the SARD cluster. So it will provide the interface between these two, this and this. Okay, so I hope you understood. In the next lecture we'll see in detail. And the next is config server. So what is config server? Config server actually stores the metadata. So it is actually a metadata for our SARD clusters and all the SARDs and the replica sets inside the SARDs. So it will actually have the metadata and also the configuration detail. So configuration, config settings and all for the servers will be here. So, and this will also be a replica sets. Okay, so this SARD is replica set, and the this MongoS is the interface between the application client and the SARDing cluster, and this config server is actually a metadata and configuration setting, and it will be hosted on a replica set. Understood? So it is also a it must be, this config servers must be deployed on the replica server. Okay, replica set, deployed as a replica set. So this is SARD, MongoS and config server. These three are the main component of the SARD cluster. In the next lecture, I'll show you how the architecture of the SARD cluster looks like and how we can understand in a much better way. But for now, it is enough to know that SARD, MongoS and config servers are the three main components of the SARD cluster. So see you inside the next lecture, where I'll show you the architecture of the SARD cluster and much more. So in the previous lecture, we have seen what is SARDing and what are the components of the SARDing. So we know that there are three components of the SARDing, that is SARD, config server and the router, that is MongoS. So in this, I'll show you how in picture they look like, or the architecture, or the how they communicate with each other. Okay, so suppose we have a app server running here, the app or the client here, and we have SARDs here. So SARDs are the data sets that we have split it over the multiple machines. Suppose we have SARD 1, SARD 2, SARD 3 and SARD 4. We also know that all these SARDs are replica sets, right? So this replica set will contain three different hosts or 3 or 4 hosts. So this is the replica set. Similarly, SARD 2, SARD 3 and SARD 4. And when we want to communicate to the SARDs or the data or the documents which we are keeping on these SARDs or on this replica set, what we can do, we cannot directly communicate to the SARDs or the data stored on the SARDs. What we need to do, we need to go through the router. We need to go through the MongoS. So MongoS is a router through which we can communicate to the app. So app will communicate to the MongoOS and MongoOS will be communicating to the different shards. So this MongoOS will have some of the things, some of the configuration that it can communicate to the different shards, and it can get back the what is requested by the app server or application. So here we can have multiple shards, we can have multiple app routers, we can have one or more routers. So we can have one more MongoOS here, not a problem. So depending on the requirement, we can have the multiple MongoOS, okay, and they can communicate to the shards and they can get the data. And in between these apps and the MongoOS, the thing, we have the config servers, right? So config servers will be somewhere here, and this will be in between these two. So this config server will be like MongoOS will be, it can go to the router and it can go to the different shards as well. So it can have all the configuration inside the config server. So app server will go to the MongoOS, MongoOS will go to the config servers and get the details, and then it will communicate to the this thing. Or we can place it in a much better way to understand. Let me remove this. So we can, like, it can be in between the, like this, and to all the servers like this, okay. So it will have the configuration for all these shards and the MongoOS, the router. So how this MongoOS will be knowing about the data or documents stored here, and this is done through the collection level. So what MongoDB does, for each shard or each document or each collection in MongoDB, what it will do, it will use the partition of the collection using shard key. So whenever app data will communicate to this will, MongoOS will look for the shard keys, and then it will go to the shard and it will fetch the detail. So shard key will see what is that. It will consist of the field. Suppose we have a field called student ID. So this student ID, we can make it as a shard key, but the condition is it should be there in all the collections, then only it can become a shard key. So with this shard key, we can, MongoOS, the router, can go and get the details for the collection. We'll see how this shard key is defined in the next lecture, but for now it is good to know that we have the collections here. The collection will be splitted into the chunk of data, and these chunks will be stored with the shard key, and this shard key, with this shard key, MongoOS will get the details. So this is how the MongoDB shard cluster works. So we have the shards here and the shards and the app. The app will request to the MongoOS, and MongoOS with the help of shard key can get the data from the different shards, and different shards are actually a replica set, and this config server is also a replica set. It should be deployed as a replica set. So sharding and replica set will go hand in hand, because all the machines which we are deploying on the shards, actually they are the replica set, the host of machines where we have distributed our data. So I hope you guys understood this, and if you have any doubt, please do ask. I can repeat this concept again. If it is not clear, you can comment your thoughts in the comment section of the course, and I can revisit this lecture if it is not understood well. So do let me know if it is clear or not. Hello and welcome. So in this lecture we will learn more about sort key and how it is created and how we can distribute the collection on the sorts. So let's see. So we know that we have this sorts, suppose sort 1, sort 2, sort 3 and sort 4 here. We have MongoS here and we have the app here, right? We have MongoS here, so we'll communicate to MongoS. MongoS will be communicating to the sorts, correct? This way you understood, right? And these sorts are actually a replica sets, right? That we know. So now we will try to understand how, suppose we have a collection here and that collection we are distributing over this sorts. So what MongoDB actually does, suppose we have a collection, it will partition that collection into chunks. So it will create chunks from the collection, chunks of data, and these chunks, what it will do, it will split over the sorts. So this chunks of data, chunks of the collection will be splitted over the sorts. So how it is done? Actually it is done based on the sort key. So sort key is actually created from the collection. Suppose this collection is having one like student ID. So this student ID will declare as a sort key and it should be there in all the documents. This student ID, whatever field you are going to make as a sort key, it should be immutable, it should not be changing, and it should be available in all the documents of the collection. Then only it can eligible for the sort key. So suppose student ID, we made it like a sort key, and this is sort key is range based. Okay, so it is actually range based. So what we will do, we will divide this collection into chunks. So these chunks will have this sort key student ID. So this student ID, based on the student ID, it will be divided. So now this collection is divided into the partitioned into the chunks, and these chunks will be, suppose one chunk will be here, 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 and all the data documents will inside the collection is now divided into the chunks with the help of sort key student ID. So now how this application will be knowing, or MongoDB or MongoS will be knowing that where the actual data is. Suppose I want to query for the student ID equal to 10. So suppose I want to query this. So when application will query for student ID 10, what MongoS will be doing, it will have the access to the all the sorts and the chunks. So what it will do, it will immediately look for this student ID 10 belongs to which chunk. So it will look for the chunk on which this student ID 10 is there, and then it will go and fetch the detail from, suppose student ID 10 is in this chunk, so it will communicate to the sort 1. If it is on sort 3, it will communicate to the sort 3 and it will immediately fetch the data and give it back to you. So actually this is range based. So suppose 10 to 20 student ID is on one chunk. So suppose that 10 to 20 belongs to chunk 1 and chunk 2, and it is on sort 1 and sort 2. So it will only communicate, it will only scan or search inside this sort 1 and sort 2 for the student ID 10. It will not look for chunk sort 3 and sort 4. So this is what this is how the sort key and the chunks are created. So application to MongoS will look for the student ID 10, and then it will look for which this student ID sard key 10 belongs to which chunk. Then it will find the chunk, then it will look for the which chunk chunk is on which sard. So all these details will be there in the MongoES. MongoES through the config server and all, it will have all the metadata and everything. So it will have all the details about the which chunks belong to which sard and which student ID sard key belong to which chunk. So based on that, it will fetch the data. Suppose if we are not following the sard key while fetching the or creating the sards, then what will happen when you search for the student ID 10, the MongoES will scan all these 4 sards and it will take a lot of time. So that's why they have created this sard key, which is range based sard key. So it will look for the student ID 10 and it will first look for which chunk it belongs to, then it will look for that chunk is on which sard, and then it will fetch the related data or related query from that chunk, from that sars, from that replica set. So this way it is very easy to query. It is very efficient and it is very time saving thing. So that's why it is based on the sard key. I hope you guys understood this. If you have any doubt and if still have some confusion, you can ask in the question answer area of the course dashboard, and I will be happy to answer, and I'm ready to repeat this if you guys want me to do so. So please do ask your questions in the Q&A area of the course, and I will answer your questions. So see you inside the next lecture.